Okay, so we have looked at this example of one of the limit theorems when you talk about two-sided limits. And we continue looking at this. Remember now, we say this is two-sided because this is 1 and we're approaching 1. We can approach 1 from the left, that is the negative side, or from the right, the positive side. And we realized earlier that the limit, as you approach from the negative side, as you approach 1 from the negative side, is 3. The limit, as you approach 1 from the positive side, is 4. So, what that means is the limit as x approaches 1 from both sides of f of x, it does not exist. Alright? That limit does not exist. And when we look at this situation, there is a sudden jump and a break at x equal 1. From the left it is 3, from the right it is 4. So the graph is not continuous. There's a discontinuity or a break in it. Now, let us look at another theorem that is commonly used, and you probably would have used it already. This theorem deals with the polynomial and rational functions. Alright? That's the polynomial and rational functions. Let's erase some of what I have here. Let's erase the board and look at that. Now the thing is this. If you have a function, for example, f of x, now the limit as x approaches a number c of f of x is equal to f of c. See that? What that means, for example, if you have a function x squared plus 3x and you want to find the limit of that function as x approaches, say, 4, the limit of this as x approaches 4, it is equal to f of 4. F of 4 is 4 squared plus 3 by 4. So you substitute 4 for x. So it's 4 4 16 plus 3 4 is 12. So what you have is 28. Alright? So the limit of f of x as extends to c is just f of c. You substitute c for x as you approach f of c. Now let's look at an example with a rational function. Suppose you need to find the limit. Let me use a different color. You need to find the limit as x approaches a negative 3 of the function x squared plus 4x plus 3 divided by x plus 3. So you see this is a rational function. You have a ratio here, or a division. Alright? Now, suppose we just go ahead and plug the value of x directly into the function. as we approach negative 3, and remember the bracket, then what we're finding is f of negative 3, which is negative 3 squared plus 4 by negative 3 plus 3 divided by negative 3 plus 3. So what would happen? You would have negative 3 squared, which is 9, plus 4 by 3, negative 3, negative 12, plus 3 divided by negative 3 plus 3 is 0. This would finally amount to 9 minus 12. What is 9 minus 12? That's negative 3 plus 3, which is 0 over 0, which is indeterminate. First of all, you cannot say this is 1 just because you have 0 over 0. And the other thing that you consider is that you're not allowed to divide by 0. So it is in an indeterminate form. So we have to go back and do something else. How do you deal with this situation? Now, if you remember how to deal with quadratic expressions, one of the ways that you could deal with this up here is to factorize. So suppose we factorize x squared plus 4x plus 3. One quick method is the AC method. The number that multiplies x squared is 1. In the form a x squared plus bx plus c. A is 1, b is 4, c is 3. A times c is 1 times 3, which is 3. What are the numbers that multiply to give you AC, which is 3, and they add to give you 4? Let's see. I know that 3 and 1. 3 times 1 is 3. 3 plus 1 is 4. 3 and 1. They multiply to give you 3, which is AC, and they add to give you 4, which is B. So let's try that. 3x squared plus, split the 4 into the 3 and the 1, so 4x becomes 3x plus 1x. I'll write the 1 there, plus 3. So factorize these two first expressions. So you have 3x outside the bracket, you have x plus 1 inside the bracket. Then factorize this. What you have is plus 1 outside the bracket. Get rid of the line. Yeah. Plus 1 outside the bracket. X. What we have? 3. Let's see if everything is okay. Oh, a mistake here. I should not have written 3 in front of this. It's 1. Where did I get that 3 from? Let's continue. So, factorize these two expressions. So you have x outside the bracket. You have x plus 3 inside the bracket. Then factorize these two. What you have is plus 1 outside the bracket, x plus 3 inside the bracket. And you ensure that you have the same things inside each bracket. Then you take the bracket as a common factor and put it out of a new bracket. What you have here is x plus 1. So you have x plus 3, x plus 1. If you multiply these two, you should get back x squared plus 4x plus 3. So, let's go up here and continue working it out. What you have, all of this, what does it amount to? It amounts to the limit as x tends to negative 3 of x plus 3 times x plus 1 divided by x plus 3. What happens here? X plus 3 cancels x plus 3. So what you're finding is the limit as x approaches negative 3 of x plus 1. Now, f of this, f of negative 3 is just negative 3 plus 1. So what you have as the answer now is negative 2. Alright? So what you have there is negative 2. So this theorem states that as x tends to a number c, the f of x, the limit of f of x, it is equal to f of c. Now, before we finish this video, let's look at what the graph of this looks like. What does the graph of this look like? Pardon me, I recently caught a cold. The change in the climate, and this almost always happens. Alright, so we want to plot. What do we want to plot? X squared plus 4x plus 3. So we're going to plot x to the 2 plus 4x plus 3 divided by x plus 3, x plus 3, go. Alright. Let me make this thick so you can see it clearly. Now, this is the graph. Alright? This is the graph of the function. And we're saying that as x tends to negative 3, the limit as x tends to negative 3 is negative 2. The limit as x tends to negative 3 is negative 2. Where is negative 3? X tends to negative 3. We have here negative 3 here. And we can see right here negative 2. As x tends to negative 3, right at this point, x is going towards negative 3. The limit is negative 2. I can see where they coincide. Alright? Okay, good. So that's what we have. That's what we have there. So we've looked at the graph of this function, and I've seen that as x tends to negative 3, x is equal to 2. The other thing we want to do is look at the graph of x plus 1. Just x plus 1 alone. So x plus 1. Alright, x plus 1. You see, both of them coincide. This is a new graph. But they are the same thing because they actually cancel out to be the same. Alright? So let's put this back and we have both graphs coincide. Alright, good. So I'll see you in the next video.